Hello guys, welcome to my YouTube channel. This is another episode on that is algebra, which is complex numbers. So if you've watched my previous videos, I've talked about complex numbers, and here we are going to take some difficult examples of complex numbers and try solving it. Yes, and please, this video is in two parts. One is for tutorial and another one is how to use the calculator to do some part of this calculation to make you work faster. So we are going to solve the examples on complex numbers. So we have 4 questions here that we're going to tackle, and please make sure you watch to the end. And thank you for your subscription. And if you're not subscribed, please check the subscription button and subscribe for more videos. Thank you very much. So now we have 4 videos that we are going to discuss, and if you've checked my previous video on how to download a TikTok video without watermark, well, you can create your own TikTok account and just download these videos and just download and compile them and just post on your TikTok. And also, well, we don't know what might happen. You might just get some money on that, and also you can also do that on what, Facebook. Yeah. So now there are 4 questions that we're going to tackle here. The first question is the second question, third question. So please make sure you watch to the end. So we are going to take the first one, that is solve into bracket 1 plus 1. That's 1 plus r exponent 9,999. Okay, sure. This question is somehow you cannot solve it with the calculator, but you can solve part of it with the calculator. So we need to first thing we need to do is we need to find the argument and the modulus of this complex number. Yes. So when you find the argument and that one, I'll use a calculator. So after this video, I think the next video following this video will be that is the same thing, but after this section you have another section which is the calculator part. So you see from there. So now with the exponential representation of or polar representation of complex numbers, you know this already. That is the modulus, and it can be expressed in the what, exponential. That is the polar representation. So this is also expressed like this. Now what we need here is the modulus and also the argument. So how do you find that? Well, you can do that with the calculator, simple as that, but well, you can also do that by calculation. So now we need for you to find the modulus, that's the square root. From my previous videos, I taught how to find the modulus with a formula and also the argument. So when you do that correctly, you get the modulus to be root 2 and the angle is pi on 4. Yes, so pi on 4. You know that pi is 180, so that's it. So after you getting this, what you do now is just substitution. So we try substituting it because now we have the r here. This is the r that we have here. We have the r here. We have the pi here. That is the angle. So when you do that correctly, you have this. You have this. Now, how do you solve this? Now, for us to solve this, one thing you need to do is that we need to use the law of indices to break down this. So we need to break down this 9,999 into a way that we can solve. So what you do now is, you know that this is going to affect that and affect that, this because it's multiplication. Yes. So you get root 2 over, that's root 2 exponent 9,999, and this, all of this. But this one, if you are trying using calculator, you cannot solve. So we need to do something about this by breaking it down. Now, when you break it down, that is, you are going to separate that. When you add the 3, you know that this is the same thing as this. I'll tell you something, the reason why we did this. So when you do that correctly, you're going to get this because we've separated it, right? So this is multiplying this, and there, if you check from the previous slide or the previous this one, you know that the I pi will be multiplying this, right? So this actually is multiplying this. Yes. So I think here should be over 4. Yes, over 4. Yes. Now it has been done. That is it. Now after this, we expand it because using a lot of indices that help us to expand this. Now after getting this, we need to do something about it. We need to reduce it. Now when we reduce it, we get something like this, because you divide 9,996 over 4, and that will give you 2,499. Now when you do this correctly, note that with regard to the e, when the e is with, or the pi is with an odd number, it is a negative number. Like when this, the value of this, when the value of this is odd, it becomes -1. and when it is even, it becomes 1. Please note this very well. Note this: when the value of this is odd, it is -1, and when it is even, it becomes 1. So from there, you know that this whole thing changes to -1. Yes, this whole thing changes to -1. So time that. And when you do that, it means that you're going to represent it in the, we have the, is it the molar or the polar representation? That is the same thing as this. So for this thing, you have done with it. Now you can try to break down. You can do more thing about it, but I think in the answers, I think you'll be able to see this possible answer inside. If not, they will change this to angle, and you do that. So that one is very easy. So this is what you need to know. What I said again, that the main thing is that if this is even, it becomes 1, and if it is odd, it becomes what? -1. Please, let's continue. So when you do that correctly, you're going to change this into a complex number. This is a real and imaginary. So your major answer will be this. Now let's move on to the second one. As in with the second ones, we have a different way of solving it. That we are going to use the natural logarithm to solve this. Yes, so that we can help us to break down things. So if you get any question in complex number that look like this, you need to use natural numbers. That is the natural logarithm. So with this, you take the natural log of both sides. And with natural log, as you know, the logarithm, when it's the exponent, you can break it in front. Yes, so when ln 2 exponent I plus 3 is equal to ln x, this can be represented as 3 plus I ln 2 because we are using the principle of logarithm. Yes, you should know that. So when you do that, now what do we do next? What you do next is that we are trying to eliminate the ln. So we take the e exponent of both sides. That's the e. When you take it, this e will take care of this ln. And wait, okay, sorry. So this e will take care of this, and you get what? Let me come again. This e will not take care of this because this one is with that, right? Let me do it again. So let me erase it. Let me erase it. Sorry for that. So I've erased it very nicely. So now when you do that, this e will take care of the ln. So now you get z is equal to, now the ln 2 here, e exponent ln 2 is 0.693 bracket open 3 plus I. So you can therefore simplify this, and when you simplify, you're going to get z is equal to e exponent 2 plus. So this is a, so you can find the argument. So you can represent this with the I and also the angle. The angle to find, you know how to find the angle. Yes, with the tan inverse of the y component over the s component. Yes, so please, you do that. Are you getting it? Okay, sure. So after that, so to be frank, this will be the raw answer, but you can therefore go down to or simplify this. Yes, so you can do that on your own because with that place you can take care of this. So when you do that correctly, you're going to get it because I tried finding the angle, right? So the angle will be 18.435 I. That's it. So let's move on to the next question, which is question number 3. With question number 3, that one too is different way of solving it, which is 3 minus 5i all exponent 4, right? All exponent 4, right? So with this one, we have a formula for it. It is different from the other one. So please make sure you look on what I'm doing. So with this, as in you find the modulus and argument as a normal way. So the modulus will give you root 34 and the argument will give you -59. So when you do that correctly, this is the formula you must put in your head. This one. So when you know this one, it's very simple to solve this kind of question, right? So now what you do now is substitution. We have our modulus and we have our angle. So, and it can also be reduced to this form. That n will come here and this will be exponent 1. So when you do that, you're going to get as in the root 34 exponent 4 times cos n, cos the angle, which is -59. That's the argument, and the I exponent 4. So let's reduce this. When you reduce this, as you know that since it is 4, it will be 4 times 1 over 2. And when you find the half of b, you're going to get 2. That's why you had this. So when you reduce it correctly, you're not going to get this. So when you square this, you get 1156 and this. Now you can try to reduce this to the simplest form by using this formula. That is, you bring this 4 times the argument, and this 4 times the what argument, and you reduce it. Yes. Yeah. So let's go to the next one. Where this one too is different from this. So that one too, we have a formula that we use, which is this. So always you need to put this thing in your head. Now note, the k is an interval, right? So they will give you the k, find the all the solutions. So this one, they didn't give us that we should find all the solutions. So we are just finding when k is equal to 0. Are you getting it? But if they say find all the solution, you need to, maybe it's exponent 1 over, you need to do all the solution. So with this, what you do now is just substitution. First, you need to find the argument and the modulus. That's the main important thing. And when you do that, you just what? Substitute. So if you can see, just substitution here. And since k is equal to 0, it will be gone. So when k is equal to 0, it is gone, right? And when you divide negative 30 by 8, you get negative 3.75. And with this, it will be 2 exponents 1 over 8. And you're going to multiply through with that. So when you multiply through with that, this will be your raw answer. So actually, this is the answer for the question. It's very simple. What you need to know is just take the formula in your head and actually try and just do substitution. The main two things you need to find is the modulus and the argument. Please, the following video that is coming is about how to use the calculator to find the modulus and the argument. And please try your possible best. If you've not subscribed, subscribe to my YouTube channel. Thank you very much.
Okay, so this is a calculator. So what you need to do is, the first thing you need to do is we need to activate this in a complex mode. So you go to mode on your calculator, and when you go to mode, you press mode, and on your calculator the complex is number 2, so you choose number 2. So when you do that, you activate the calculator into a complex mode. So what you now do is you put down your question. That is, the question is root 3 minus I. The I is in. Now what you do now is you press shift on a calculator, shift, and you press 2, the written complex. So you press 2. Now when you do this on your calculator, I think we have 1 to be the argument, 2, so it's the same thing, right? So you go to, on the calculator, the modulus and the argument is 3, so you go to 3, that is this. So when you go there, now it has given me the answer, as you can see. So with this, I have my argument and modulus, and I can use to solve my questions. Thank you very much for watching this video. Please subscribe.